Okay, now we're going to look at backward pass or backward schedule. So we're going to begin from the end of the project, starting from the finish time of the project. So finish time of the project is that, right? Okay, so we're going to start from there and work backwards. And when we work backwards, we have to do everything backwards. So in the forward pass, we first came up with the earliest start time and we added the expected time to get the earliest finish time. So in backward pass, we have to do latest finish time first. So LF is latest finish time, right? And then we subtract from the finish time expected time T and we get the latest start time. So this is ES plus T. Here that would be LS is LF minus T, right? So latest LS is latest start time. Okay. So again, we look at arrows going out. Okay. In the forward pass, we looked at arrows coming into a node. In the backward pass, we look at arrows going out. Okay, so here for this activity, there is only one arrow going out. So whatever the finish time is, that is the time by which you have to finish this activity. Okay. Now, if you have more than one activity representing the end of the project, each and every one of those activities will get the finish time irrespective of what the earliest finish time was. All the finish times for the activities at the end, one or more, they all must get the same project completion time as the finish time. So then take the finish time, subtract the activity time, that will give us the latest start time. Okay, and the latest start time formula is the same for all the activities, so we can copy that. Okay, so here the latest finish time for G is there is only one arrow going out, so the latest start time for H, that's when G must be finished. Okay, so this is the latest by which H must start, and therefore G must finish at the latest by that time. So if G doesn't finish by 13, then H cannot start by 13 and the project will get delayed. So this is the latest time by which G has to finish, which means it has to start by 8. So same here, there is only one arrow going out, so the latest finish time is the latest start time for H. Okay, and start time is we copy paste that. So going back further, okay, so now let's get to E. E has only one arrow going out, so the latest start time for G, that's the latest finish time for E. Once again, we can copy that for this start time. Okay. Now D, again only one arrow, so which is that. Okay, and then we can copy this over here. Okay. So now C has two arrows going out. So C must finish in such a way that F and E are able to start no later than the latest time by which those activities must begin. So F cannot begin any later than 10. So C has to be done by 10. E cannot start any later than 4. So C must be done no later than 4. So these are the two possible times, and the smaller of these two times is when C must be done. So we use the min function. So everything is backwards in the backward pass. In the forward pass, we looked at the arrows going out. We looked at the earliest finish time and we did max. In the backward pass, we look at arrows going out. We look at the latest start time. We look at the min of those latest start times. So here that and that. So that's when C has to finish no later than that. So now copy that over. Okay, so going further back, okay, A has only one arrow going out, so that one, and copy that formula here. Okay, this has only one arrow. Okay, so copy that. All right. Now the start has two arrows going out, so we use min of that and that. Okay, so you get 0. So when you go backwards, and you have to do this min function for the start block too, just to make sure that everything is okay, because if this min is not 0, that means you made a mistake somewhere around here. When we go backwards, we have to go back to 0 for the start block. Okay, now we have the earliest start and earliest finish time, latest start and latest finish time, and as you see that there are some activities for which they both are the same and for some they are not. So for those that are same, that means the earliest time is the same as the latest time. We don't have any cushion. There is no slack. So slack is defined by, so slack, activity slack. So slack is defined by the difference between it can be latest finish time minus earliest finish time, or it can be latest start time minus earliest start time. They both must be the same. So we can compute the slack. Okay, slack is the latest start time, the latest finish time minus earliest finish time, or we can compute that with that also. So both are same. So this is the same formula for all the nodes, so we can just simply copy paste, and you see that when the earliest and the latest times are the same, slack is 0. Okay, otherwise there is a slack. So the ones with slack are the non-critical activities. So B, D and F are non-critical. So slack 0 or critical. So we can do conditional formatting, okay, for all of them. So should have done it before copying. So let's do conditional formatting, highlight rules and equal to. So if the slack is 0, then you highlight. Okay. All right. So now I'll copy that everywhere on all of these boxes. I did control click to click. Okay. So I have to do here as well. So the ones with slack is 0 are highlighted. So you have A, C. Oh, I forgot to copy that over there. Okay. So A, C, E, G, H is the critical path, and they all have slack 0. And B has a slack of 1, D has slack of 1, F has slack of 6.